All right, so this is called the families of graphs, right? We've talked about this. I think we did a lot of this with the absolute value. Remember we shifted it to the left or the right. We shifted it up or down. Okay, remember that? Okay, and what does it look like with absolute value? So for instance, if I gave you something like this, and again, this is something that we've already talked about this year. So what if I gave you y equals absolute value of x minus 2 plus 3? Would you be able to graph that like pretty quickly?
Probably.
So what does that mean? What does this mean right here? What does that do? First of all, it's an absolute value. So what's it going to look like? It's going to look like a v. Would you agree? All right. So that's what the absolute value is going to look like. What does that 3 do to it, though?
It shifted to the
Up 3, right. So this goes up, and this goes what? It looks like it would go to the left because there's a minus, but it really goes the other direction. So this actually goes to the right.
What is it in?
Right.
Absolute value, dude.
Yeah, but it's not just because, listen, no, don't be too full of yourself right now, okay? It's not because it's in the absolute value, because there's other things as well. So for instance, watch. I wasn't going to get into this, but since we're here, what if I did this? This is a square graph, y equals x squared, okay? That would be the family. When they talk about the families of graphs, this would be more like a specific. This would be like a son or a grandson or a daughter or a granddaughter of the graph, okay, of the family. But here's the papa, okay, y equals what? Look, see, y equals x squared. And we're going to show it to you in a little bit. Again, we're going to use Desmos to do it a lot of this, okay? So y equals x squared. Now look, this still moves it to the what?
Right.
Yeah, not because an absolute value, right? It doesn't, well, it is squared, that's true. But it's not because it's an absolute value and everything in the absolute value is positive, okay? It's not because of that. They don't give you the equations on this. I think eventually they might. I don't think they do on this lesson at all. But if I remember right, again, it's been a long time since I've done this stuff, but y equals, I think they put a letter out in front, like put like a plus or minus. Man, I'm really stretching my memory a little bit here. It's like x minus, I think it's h, like squared plus k, all right? So this means how, well, first of all, the plus or minus. What do you think a minus would do if I had a minus out in here? I think we've talked about this before. It doesn't shift it, it flips it, right, okay? It flips it, it reflects it, okay? So it flips it down. So the plus and minus means if it's plus, it means it goes up. If it's minus, it means it what? Goes down, okay? This is x minus h. This is part of our equation. So if this number right there was just a 2, this means it goes to the right 2 places. You see it? Because negative is part of our formula, our equation. I didn't really mean to get into that, and so let's stop that right now. Okay, so let's go to Desmos, and there we go, and put some things in here. So, and you can write some of these down. If you want to write like a little sketch of the graph, it doesn't have to be like a perfect graph, but, and let's zoom that in a little bit. So let's talk about the first one. The first one they call a constant function. Okay, you can write that down, constant function. So that means y equals just a number, right? So before I put a number in there, I'm just going to put any number. What kind of line is it when it's y equals just a plain number? Slope, that's the kind of line it is? No. They're all straight lines. It's a straight line. I mean, is it horizontal or vertical? I got both of them.
Horizontal.
What do you mean up? Vertical? So when it says y equals, all right, listen, back here. So when it says y equals just a number, what does that mean? It means where the line goes through the y-axis, it's y equals. So what kind of a line is if it goes through the y-axis? It's a horizontal line. So the birthday girl got it. All right, so what if I put y equals 2? What's the line going to look like?
It's a line going through 2.
And it's what kind of a line, though?
Horizontal.
Boom. There it is. Okay. There's your horizontal line. That's y equals 2. Let's try another one. What if I put y equals -2? What would it look like? What kind of line? Okay. Horizontal line, right? If I put a -2, there it is right there. See, it goes through there. Everybody with me on that? Okay. So that would be a constant. Let's do another one. Let's put x equals something. X equals. I'm going to put a number in there. I put a small number in there, but what is that going to look like? It's a vertical line. So give me a number, like -3. There you go. See, there's x equals -3. All right. Everybody with me on that? Watch, this is kind of interesting. I just found this today. Look, it's got a little slider. You see it? So if I put x equals 2, it still goes to, it's a vertical line. All right. So that's a what kind of a function? I told you to write it down. That's a constant function, okay? The one I just finished doing. Okay, when it's y equals a number or it's x equals a number, that's called a constant function because it never changes, right? It just stays whatever that is. All right. Here, the next one. Again, I'm not writing this down because I don't want to go back and forth. I might be able to actually type stuff in. Identity function. Yeah, I can do that. Yeah, that's cool. Should have done it up here. All right, so identity function. Identity means it looks the same. So your basic identity function is just y equals x. So that, and you've seen that before, right? Because we talked about it being symmetric about the y equals x axis. That's an identity function. All right, pretty easy. And I don't know if they consider y equals -x to be identity function or not, but that's what I would write for identity function. Now, we just finished talking about this, so let's put this down. This is a polynomial function. All right? And it looks like this. We've talked about it a little bit at the beginning. Oops, I got to use this. I don't know how to do a square without this thing. So y equals x squared. All right? All right, so there is y equals x squared. These are your family of functions, okay? These are what it basically looks like. Now, you can change it around a lot, right? You can shift it left or right. You can shift it up or down. You can make it wider. You can make it skinnier. You can flip it. There's a lot of things you can do with this stuff, okay? But this is your basic granddaddy function, okay? This is the OG function, all right? Everybody got it? So it's a polynomial. It's right there. It's a polynomial function. All right, you got that? Okay, I'm getting rid of that. Everybody good? Okay. And we're going to talk about moving stuff around here in a second. Here's another polynomial function, okay? Y equals, by the way, this thing right here, we have a name for it. Anybody know the name of that curve?
Oh, I know.
Starts with a P.
Parabola.
Parabola, okay? All right. All right, so watch this one. Y equals, let's go the next one up. Let's go cubed. So I hit 3. This is another polynomial function, all right? But that's a y cubed. You see the difference. Now, why did the x squared just go up and the cube goes down? Because if I put a negative in for an x and I square it, what am I always going to get? I'm always going to get a positive, okay? But if I put a negative into an x squared, I could get a what? I could get a negative. But if I put a positive into an x cubed, did I say that right earlier? Anyway, I meant into an x cubed, okay? If I put a negative into an x cubed, I could get a negative. If I put a positive into an x cubed, I get a positive. And that's why it looks like that. It kind of looks like half of it is just a reflection. It's a parabola, but we just took half of it and we flipped it over. Doesn't it look like that? Yeah. But if I put them both together, watch. If I put them both together, you see the how much it slants up, okay, how much it turns up, definitely changes. The y cubed turns up a lot faster. For instance, let's put a 2 in for x. So y equals 2 squared. What's y equals 2 squared? 4. So if I put a 2 in, then I go up to where? 4, right there. You see that point right there? There's 2, 4. What if I put a 2 in for an x cubed, though? What if I put a 2 in for x cubed? So what's 2 cubed? It's 8. All right, so watch. If I put a 2 in, there's the 2. That's the 2 line right there. Look, it jumps all the way to 8. See it? If I could get it to work. There, oh, almost. There it goes. There's the 2, 8. Everybody see it? All right. So you get the idea with that. Let's zoom that out. So that's the difference between an x squared and an x cubed graph. All right, good enough. That's polynomials. And we could do things. We can shift it around. We're going to talk about that in a few minutes. I'm going to go through all these families of graphs. So we had an x squared. What do you think the next thing we're going to do? X squared. What's kind of related to an x squared? It's like the inverse of an x squared. No? If it's squared. What's the inverse of squaring something? What's the opposite of squaring something? Square root it, right. So, have you ever seen a square root? Would you have any idea what a square root graph looks like? Well, now you will. So watch, y equals the square root of x. And that's what it looks like right there. Again, look, it doesn't even have any x or negatives for the x. Why not? Why can't you put a negative in for the x? Why? Because of square root. You can't take the square root of a negative number and get a real number out of it. Okay, you would get an imaginary number. That's a topic for another day. All right? So, look, it's got no negatives for the x's, and it's got no negatives for the y's, unless you did this. I probably shouldn't do this, but watch. If I put a negative in front, what do you think it does to that graph right there? I'm going to stick a negative in front of the square root. Flips it. Boom. Just like that. See it? All right, watch. If I get rid of it, it goes to that. All right. We good with that? That's called a square root function. I should have written it down. Let's write it down right now. Square root function. And let's put it above it. Oops, went too far. There we go. All right. So there's your square root function. That's your basic, everyday, ordinary square root looking function. Now, what could we do with that though? We could shift it left or right, up and down. We could flip it. We could change like how wide this thing goes. We can do a bunch of different things to it. And we will eventually. All right. But we're just trying to find your basic graphs just so you can visualize, just so when you look at something like that, you're like, oh, that's got to be a square root function. Or the parabola, that's got to be a what? A squared function. Or the one that goes up like this and down like that. What function's that? That's a x what? When it goes up like this and down like this. That's an x cubed function, okay? So what you need to do is you need to be able to look at these things and say, oh yeah, that's an x squared. That's an x cubed. That's a square root. Everybody got it? That's an absolute value. Absolute value is kind of easy. All right, and that's what we're going to do right now. So let's write that down. So absolute value function. Oops, if I could type here. Okay, so let's do an absolute value function. So it's just going to be y equals the absolute value, and this thing has an absolute value symbol right there of x. Close the absolute value, boom, and let's close that square root. There we go. Okay, so there's the absolute value function. That should look familiar to you, right? Would you agree? And we could move it left and right, up and down. We could flip it. We could twist it. We could do all kinds of stuff to it, all right? But that's that. All right, let's see what else we got. Oh, I had to look this up because I had no idea how to graph this on here. But it's y equals, I have no idea why they do this, but they say, actually, let's do this. Let's write down what it's called first before I graph it. The greatest integer function. Greatest integer function. All right, and we can graph that. And here's what we do. Again, I had to Google this because I had no idea. If you put floor and then you put parentheses x, check it out. Does that look familiar to you? Yeah. All right, so that's your greatest integer function, right? 0, 0 is right there. Watch, when you go to 1, there's no 1, 0. So what happens when you hit 1? It jumps up to 1, 1. Do you see it? See what it did? Then if you kept on going all the way to the next integer, what does it jump up to? As soon as I hit 2, what's it going to do? Boom, right there. I hit 2. If I can hit, come on, stay there. Close enough. All right, there's 2, 2. You get it? All right, and I can keep going like this, and it goes up like that. It's kind of interesting. What if I put a negative in front of it? What do you think that's going to do to this? Let's make it a little bit smaller.
Oh, it's going to be the opposite way. The line can go.
Watch. I'm gonna copy it and paste it, and then I'm gonna put a negative out in front of there. Look what it does. See that? Instead of going to 1 and then going up to 1, it goes over to 1 on the x-axis, and it pops down to -1. See it? All right, so that's what putting a negative out in front of it does. All right. What about putting a negative inside? I'll tell you what, what if I put a negative inside next to the x? What do you think that's going to do? Boom. Goes that way. You see it? All right, enough of that. So you got greatest integer function. That's your basic everyday. Right there is your basic everyday greatest integer function. And right there, they don't really show it, but that's kind of like an open circle right there. Because once I come over here, watch, I get really close. See how that 0.96, 0.98, as soon as I hit 1, what's it do? Boom, pops up to the top, okay? So it gets really, really close to 1, but as soon as it hits 1, then it goes up, and then it keeps on going like that. So that's your greatest integer function. We got one more. This one looks really crazy. This is called, let me get rid of this and this. This is called a rational function. What is that word rational? What does that indicate? It's got the word ratio in it, and a ratio is basically just a what? It is division, but it's a fraction, okay? A ratio is a comparison between one number and another number, okay? How do we compare two numbers? We compare them as a fraction, right? 1/2. That's a comparison. So let's graph. What do you think the parent function, they call these parent functions, by the way. I forgot to mention that. Okay, remember I said the granddaddy or the daddy or the whatever I said, all right? They call these the parent functions. So what do you think a rational function looks like? Y equals what? Remember what I said? It's a fraction. So we're gonna take the inverse of the x, and what is it? 1/x. And let's go this way. That's what a rational function looks like. Your basic everyday 1/x function. Now, we could shift it up and down. We could shift it to the left and right by doing certain things to it. We could flip it, all right? But that's your everyday, that's your parent function. That's the important one, okay? The one where everything flows out of that, right? You got parents, they have kids, all right? This is your parent function. This is the one that's your, quote, normal, we'll say, function. All right? Yeah, it's kind of like your base. You could think of it like your baseline function. Everybody good with that? All right. Now what we're going to do is we're going to start moving them around a little bit. All right? They start with an absolute value, and that's a good one to start because it's really easy. The V is kind of easy to draw and that kind of thing. So let's do that. So what we're going to do is we're just going to start off with a normal absolute value. We've already drawn it, but I'm going to do it again. And then we're going to change it around a little bit. All right, so there's your every normal day, your parent function, and that's your absolute value function. You should just be able to look at that. As soon as you see that on a graph, you're thinking what? That's absolute value. Agreed? Okay? Now, it could be skinnier, it could be wider, it could be to the left, could be to the right, could be up, could be down, could be flipped, right? You can do all those things to it. And let's do all those things to it, all right? So I am going to keep that one there. So the green one, that's going to be the parent function. Let's just do a bunch of stuff to it. So let's paste it. Let's stick a negative out in front of it. What's it going to do to this graph if I put a negative out in front of it? It's going to flip it. So watch, put a negative, boom, there it is. That's what a negative does to it. Everybody see that? All right. I'll tell you what, I'm not going to. Let's do this. Let's just put a plus 2. What do you think it does to this? If I put a plus 2 outside of the absolute value, it's going to move it up 2. So there it is. See, it took that original green one and it moved it up 2. Everybody with me so far? Okay. Let's do something else to it. Let's do something inside of the absolute value. Let's make it minus again. Minus, let's say, 3. What do you think it's going to do to it? Oh, I got the plus 2 there. Let's get rid of the plus 2. Let's do the absolute. There we go. See, just by putting a minus 3 in there, what did it do to it? It moved it to the right. So what if I put a plus 3 in there? What do you think it's going to do? Whoops. Plus 3. Yeah, see, it moves it to the left. With me? All right, what if we do a combination of those two things? What if I put a plus 2? What did it do? It moved it to the left 3 and up 2. So where's the vertex of that thing going to be? It's going to be at what? Negative 3, 2. All right? So it's actually, if I asked you to graph this, would you have to do a table, put a whole bunch of points in and figure out where they're located? You shouldn't have to, all right? Because you know what the thing inside the function, inside this particular absolute value, what that does to it, all right? And you know what the number on the outside does to it. What if I wanted to take this purple one and flip it and make it go down at that point? What would I do? Put a negative out in front of it, okay? Boom, there it is. See it? That's what it did. See, it was going up, now it's going down. What made it go down? That negative out in front. See it? Okay? I don't know, what else could we do? Let's put a number out in front of it. I don't think this lesson really talks about that, but we're here. Might as well talk about it. Let's stick a number out in front, like a 2. We'll make it easy. What do you think? And let's just do it to the original one. Let's not do it to that one. Actually, let's keep the original one there, and then we'll put this one. So what if I just put a 2 in front of it? What do you think it's going to do? Make it what? Skinnier? Okay, let's see what happens. Put a 2 in front of it. Boom. You're absolutely right. It made it skinnier, didn't it? Okay, so the green was the original one, right? And the black one is the one with the 2 in front of it. It made it, I don't know if you want to say it this way, twice as skinny, I guess. Because look, if you went over 1, you went up 1 for the original one. But look at this one. If you only go over a half, you go up 1. Everybody see that? If we wanted to make it skinnier, what would we do to that 2? Make it a 3 or a 4. Let's make it 3. See what it's doing? Make it a 5. Man, we're wild and crazy. There we go. Let's make it 100. Look at that. Super skinny. Would you agree? Okay. So, how do you think we're going to make it fatter?
Oh, negative. Put green in there.
Make it negative? Listen, make it negative? Is that what you want to do?
Yeah.
Why? All right, let's make it negative.
Oh.
Did it make it wider? Let's not say fatter. Let's see. Did it make it wider? No. It just flipped it. So not making it a negative. If I put a 1 in front of it, it'd look like the green one, right? If I go bigger than 1, it's going to make it skinnier. How am I going to make it wider? Okay. So let's put what? 0.5? All right, put a 0.5. Check it out. See what it did? All right, so it made it wider. If I want to make it really wide, I could put point what? 0.9. Oh, sorry. Let's go smaller. 0.1, you said, right? All right. And if I really wanted, watch, 0, 0. Eventually, if I made that small enough, you would never get to a completely horizontal line, would you? All right. You're always going to have a little bit of slant to it, just a little bit of tilt. All right, but it approaches, right, as that approaches 0, then what happens? It starts looking like y equals what? X, which is a what? Well, actually, I'm sorry. Y equals absolute value of x. Anyway, I thought I knew what I was talking about right there, but I'm going to stop before I embarrass myself. All right, so there we go. Let's do, and we could do some other things to that as well, but let's do just a couple more. Let's do this one. Everybody watch. So what if I said y equals the square root of x? I need this for the square root of x, but then, okay, that's the original. I'll keep that right there so we have something to compare it to. All right? So let's see if all that stuff that we did to the absolute value, the absolute value, moving it left, right, up, and down, let's see if it works for that as well. So how would I move this graph right here? Let's go like that. That's better. Okay, that's your, that's that one. How would I move that like up 2 places? What would I do to that equation? Plus 2, right at the end. Let's try a plus 2. Watch. Boom. There it goes. See, the red one's the original one, right? That's the parent function, and that's the kid function, right? The one that's just a little bit different than that, okay? What if I wanted to, I don't know, to flip it? Put a negative 2? Will minus 2 work?
No, square
Oops.
by 2.
What if I put minus 2? What's that going to do? Right, it's just going to flip, or it's just going to move it down. It's the same thing. It's just moved it down. Everybody see that? So when it's on the outside, listen, when it's on the outside, it just moves it up and down. How do I move it left and right?
Take it outside the square root. Put it inside.
It was, we had it outside. Okay, put it inside the square root. Okay, so I think, yeah, it'll do it. Watch. If I put minus 2, if I put the square root of x minus 2, what's it do to that original function? It moves it, does it flip it? If I put a minus 2 inside the square root, it moves it to the right 2 places. Do you see it? All right, so if I put a minus 2, it just moves it to the right 2 places. The same exact graph, I just shifted it to the right 2 places. How could I take that red one and shift it to the left 2 places? Put a plus 2. There it is. You with me? And what if I wanted to move it 2 to the left and 1 up?
So put a plus 2 in there and then plus 4.
No, I said move it to the left and up. So the left is the plus 2, right? So I keep that plus. Don't make it minus. You said make it minus. So I keep a plus, but I put a plus 1. See what it did? Took that same exact graph, but it went here and here. How do I make that thing like wider or skinnier?
Plus 2 still moves to the left.
Yeah, just like all of them, right? It does it with a parabola. It does it with an absolute value, right? It does it with all of them. What about what if I want to make that thing wider or skinnier? What do you think I'm going to do there? Let's multiply it by a number out in front. You guys still with me? Seems like I lost some of you guys. Watch. Let's stick a number out in front. Let's put a 2 out in front. What do you think that's going to do to it? Okay, let's see it. Boom. Actually made it wider, didn't it? Okay. How do you think? Listen. Oh my goodness. If I could just teach you guys, it'd be so nice. Oops. Right? What if I wanted to make it skinnier? No, what does minus do? Minus just flips it. We've talked about that a bunch of times already.
Less than 1.
Well, okay, yeah, in between 0 and 1. So let's go halfway. Let's go half. See what it did? Whoops. Well, let's get rid of the 2. There we go. The red one's the original one. Everybody see it? That's what a regular square root function looks like. Okay, if I multiply it by a number that's bigger than 1, it's going to make it a lot steeper, isn't it? All right? So watch, let's see a bigger version of this right there. Okay? So which one was this one? This was y equals what? 2 times the square root of x. Which one was this one? Y equals 1/2, right? Or 0.5. 1/2 times the square root of x. See what it's doing? It's making it not go up as quickly. All right? But by putting a whole number in front of it, it makes it go up. Putting a negative in front of it just does what to it, though? Just flips it, okay? Did we do that yet on this one? So let's do the original one. Watch, we put a negative out in front of it. See what it did? See, it took that original one, it just flipped it. You getting the idea for this? All right. So knowing these functions, knowing what they look like should be really, it's really important because it'll make things go a lot faster for you when you actually have to graph, and graphing by hand too, okay? Not doing this. Listen to me, because you won't be able to do this on a test or quiz. Don't rely on going to a graphing calculator or a graphing program or something like that to graph them. You need to be able to do it by hand, all right? You need to know what these functions look like, what their parent functions look like, what subtracting something inside the function does to it, what subtracting something outside the function does to it. All right, you've got to know what all that stuff does, and then you should be able to graph them. And then you only got to pick some pretty easy points. So for instance, like here, let's make this the parent function again. What if I just asked you to graph y equals the square root of x? Well, what would you pick? I would pick, 0, 0, right? So you start at 0, 0, because if I put a 0 in for x, what's the square root of 0? It's 0. Agreed? I know I can't put negatives in there, so I don't even try to put a negative in there. So what's the next easy number to go to? What can I take the square root of? Real easy. 1, right? So you stick a 1 in there. So what's the square root of 1? It's 1. So I know I have a point here at 0, 0. I know I have a point here at 1, 1. What's another point I can pick? Do I want to pick 2? No, because what am I doing? I'm taking the square root of it. Do you know what the square root of 2 is off the top of your head? Probably not. It's like 1.414, but I don't want to graph that. What's the next number that you might want to put into it so you could graph it?
4.
A 4, right, because the square root of 4 is 2. So check this out. Here's 4, and there it is, right there. See it? Boom, right there. 4, 2. Right? Once you have those 3 points, do you really need any other points? That's enough to get your graph going, isn't it? Put a 0, 0, put a 1, 1, put a 4, 2, and you know it's going to curve up like that, and then that's how you graph it. It's really not that difficult. Now, what if you're going to put a negative 3 inside of it and a plus 2 on the outside of it? Right? That just means you start where? If it was a square root of x minus 3 and then plus 2. What does that minus 3 mean? You move it to the right 3 places. And then the plus 2 means you move it what? Up 2 places. That's your starting point. That's your origin, basically. Agreed? And then, how do you graph the rest of it? Well, just go 1 to the right and 1 up. Then go 4 to the right of that particular spot, and then go up 2. And then you got your graph. Boom. Looks like that. Does that make sense? So that's how you graph these things. We didn't get to the... there's a few other things that we didn't quite get to. If we have time tomorrow, hopefully that thing tomorrow is not going to take our class. It shouldn't. There's no way they're going to take 2 periods to do that. Okay, I hope not anyway. So we'll try to finish this up tomorrow. Did I give you, what did I say we were going to do? It says 20 to 25. Do as many of those as you can, okay? I don't have it right in front of me, so I don't know exactly what 20 to 25 entails, but do as much as you possibly can with 20 to 25, okay? And then you'll be good. All right, have a good one.